Hello, we're the Deakin Capstone team. I'm Peter Wells,
I'm Brian Calvona.
I'm Nick Mack.
I'm Michael Wenzel.
and we're working on a project for Deakin University in Australia.
And for those of you who don't know, as you just heard, Deakin University is a university in Melbourne, Australia. It was established in 1974. Our sponsor, Iman, he teaches an embedded systems class there that focuses on using like Raspberry Pi and other devices for students to kind of create their own projects. The computer science department over there works with a lot of Raspberry Pis and more of the hardware, and then they're kind of integrating their current curriculum into what their computer science program, because it's a relatively new degree over there, so they focus less on the programming, whereas our project here is more about the programming than the actual hardware of the systems.
The problem we were approached with at the start of the semester is that we're in a transition period to fully autonomous vehicles, self-driving cars and whatnot. And drivers aren't necessarily ready or financially capable of making that change yet, so in this transition period between current vehicles and self-driving vehicles, there's a growing need for driver assistance technology, which kind of bridges the gap. You're still able to drive the car, but you'll have a smart navigation system that can do plenty of things, telling you when to turn off at a gas station because your car is telling it that it's low on gas, and just kind of predicts the driver's needs.
Yeah, think like autopilot for planes, but for cars.
Yeah, exactly.
Yeah, so the big picture of the solution that Iman was thinking of is not having a navigation system that works inside the car but works alongside the car. It takes in data from the car and other sensors that are on the car and uses that along with the GPS system to add a safer and more easier experience for the user while they're driving on the road. Some scenarios that we took into account when we first started this project, as well as throughout the project, where we were looking at users who would either be driving a long distance or in new places, and they might not know where they're going, so they'll need navigation and routing to get from point A to point B. But along that point A to point B, they might run low on gas and not be able to get to point B. So how do they get there? Well, our system would then guide them to the closest gas station so that they can then reach their point B. Or maybe they're looking at a longer trip and weather's going to become a factor that can cause problems on their trip. Our system would then warn them about those weathers and give them correct advice to then combat the weather conditions.
So I'm going to talk a little bit about our project scope and limitations. And what I mean by project scope is kind of like what we are working on, what us four have been working on this semester. So the big picture is kind of like, okay, we're going to use, you're going to read car data, you're going to have an application in your car, it's all going to work smoothly. But what we're working on is kind of making a proof of concept for a lot of the features that they want. So like the weather data, the finding a nearby fuel station when your gas is low, things like that. So kind of just making sure those things work, and then in the future, so that the future developers, whoever takes us on this project next, can kind of take that and work on it and improve it. Some of the limitations that we have, like I said, we are not able to directly connect to a vehicle, like using an OBD2 scanner or anything like that. So right now, for vehicle data, we're just going to use mock data that we've hard-coded into our program. A little bit of a time constraint. We've only had a semester to work on this. We've started from scratch, so Iman didn't give us anything to work with, so we built our application from the ground up, finding the APIs that we needed, making our GUI, and things like that. And we're also limited to the GUI itself, so we're using something called Kiwi library, which is works with Python, and we're basically just limited to whatever Kiwi can give us.
So before the midterm, we shared with you guys what we did in Sprint 1 and Sprint 2. Sprint 1, we were kind of starting from scratch. We built the basics of what our program was going to be. We set up classes, libraries, found APIs that we were going to work with. And then in Sprint 2, we then started building on the routing aspect of our application. We started implementing just the very basics of routing, getting from point A to point B and drawing a line between those on US roads. 3, 4. So what you actually want to see from midterm to now, we have completed sprint 3 and 4. During sprint 3, we implemented our routing data, or our routing that we did in sprint 2, along with live data. So now, while you're out in a vehicle, it actually follows along a line with your current location and along a route. As well as we started our service station implementation, which is the gas station feature that will, when you're running low on gas, it will tell you where the closest gas station is and how to route through that, or how to get there and then get back onto your route. In sprint 4, we started to fix problems that kind of came up over sprint 1, 2, and 3, but were minor bugs that didn't affect the overall program, but we felt needed to be fixed before we handed it in at the end of the semester, as well as other problems that service station implementation came along with, and then as well as implementing the weather API and the features that came along with that. A lot of that came down to a lot of graphical interface stuff of just showing like weather conditions and other implementations like that.
User stories that we focused on for these last couple sprints, sprint 3 and 4. In sprint 3, focused on the user story as a driver. I want to be alerted when my current fuel level will not get me to my destination, so I know to pull over at the nearest service station. As Nick was saying, this was done using mock data on our side because we don't actually have a way to read vehicle data. But it will use, what's the API called? My gas feed?
Yeah, my gas.
Yeah, it uses the My Gas Feed API to get the nearest service station to your current location. In Sprint 4, we focused on the user story as a driver/navigator. I want the program to tell me about problematic weather along my selected route so that I can drive safer. And again, as Nick was saying, that is the weather API that we are showing just temperature, current conditions, letting the driver know, hey, turn on your lights if there's rain or anything like that.
Looking at some of the resources we use for hardware, our sponsor Amon supplied us with a Raspberry Pi 3 and a GPS hat, which fits right on top of the Raspberry Pi. For software, like it was said, we use the Kiwi library, specifically the maps part of it. We had the open source routing machine, which allows to supply a starting and ending locations, and it'll find a street route that is the fastest and return it to us. The My Gas Feed API, like Peter said, supplies service stations within a certain radius of any given location. And the Open Weather Map API obviously supplies weather data given a location. So the setup we have here, the blue board on the top is the GPS hat, and that's connected into the green board on the bottom, that's the Raspberry Pi. It's connected through GPIO pins, and through pins 14 and 15 creates a UART serial communication, which allows us to read the GPS data through the TTYS0 file. Before we can read any GPS data, we first have to send the module some commands. The first command is the PMTK314, which allows you to specify what kind of data the GPS returns. And because all we want is position data, we only require one type of data to come back. The second command we have to send is the PMTK220, which specifies how often we want the GPS module to send us updates, and we've chosen once every second. This is an example of the OSRM service. All we have to specify is starting coordinates, ending coordinates, and if we want to stop anywhere along the way. It will return this JSON response. This is truncated, obviously, but it includes the route coordinates and info about each leg of the route.
Demo. Swap over to
Do you want the video or the
Python one. I'll take the reins here. So yeah, this is the GUI we have for our map right now, it's not the cleanest, but the focus of the project wasn't on the actual UI. It was just on the various use cases. So we didn't put terribly large amount of effort into how pretty it looked. Right now, as when you boot it up, it drops a pin on Niskanen Apartments over by the Fargo Dome, which is definitely not where I live. But we can do anything with the mock controls on the side here. We have routes to the OB, movies, mini golf, as well as mock gas sensor data here, where we can increment or decrement how much gas is remaining in the gas tank, because again, we don't actually get that out of the vehicle. We also have a couple controls to toggle whether cruise control is on or off, and whether the lights are on or off. And yeah, so we'll try a route to the movies here. This sends our current location as well as the coordinates of the movie theater to OSRM, which then generates this route. When we're in mock mode like we are now, we can click start driving here, and it'll just start moving the user along the route, which is what we use for the majority of our development, just again because in order to test it with real data, we had to get in a vehicle and drive around, and that was a little difficult with the Pi. But as the user's driving, say they use up all their gas, they get under 1 gallon, I'll ask them if they want to reroute through a service station. Clicking yes, we'll make a call where it now reroutes through that service station, and the graphic for the pin doesn't seem to want to load, but that's fine. Once it starts doing that, it'll actually get here where there's a closer service station. That's not showing up right now, is it? Yeah, there's actually we found a closer station. Would you like to reroute? At that point, they can hit yes again, and it would reroute them. Those pins just aren't loading. That's fine. There is a slight delay in the gas station route. Oh, I forgot to actually give them more gas once they got there. Yeah, they have more gas in their tank now. But yeah, they lost my train of thought here. Yeah, they can reroute through a service station, but when they hit yes, it has to make a call to the gas station API, which unfortunately does take a couple seconds to actually get a response. And while they're driving along a route, that can cause an issue where they hit yes and then they pass the turn to get to the service station. So then it has to reroute them a longer route than they initially thought. And we discussed that with Iman, and he was of the opinion that because this, again, is more of a test project and just to show that the capabilities are there, that delay is just something we have to deal with. It doesn't really affect things, but that is why there was some wonkiness with the delay upon hitting yes there. As you can see, this temperature down here is given to us by the weather API, and if it was raining right now, a little note would show up here notifying the user to turn their lights on. Oh, it's down at the bottom. Turn on your headlights. I see.
We
Yeah, you
forced
change-
it to assume that it's raining at all times, just for demonstration purposes.
Right on. Yeah, I can't see red very well, so that would do it. But yeah, that is how we did the majority of our testing. We do have a video. Where is that on here? Firefox. Aha, I see. So this was taken a couple weeks ago. We were doing a presentation for Iman's class in Australia and wanted to show them what we had been working on. This just kind of shows the physical setup we had to work with when we wanted to try actually driving with the Pi. So we were in Brian's car, cruising along with our laptops in our lap. The Pi was just sitting up on the dashboard. As you can see, the GPS is the blue thing on top there. There's a red light that'll blink every like 10 seconds when it has a GPS fix. And as we were driving, we just had to, there it blinked. We just had our laptops in our laps, and we were connected through VNC. So this is what the Pi was outputting. Because we were over VNC, all running through Brian's phone as a hotspot, it was pretty laggy. It kind of blinks a lot because it takes a while to actually show us what we're seeing. But we were able to punch in a route real quick there, gave it to us, and what's interesting with when we're driving normally and not using mock data is it won't remake the call for like every single time it has to redraw the route. It'll just use your current location and do a little bit of magic with distance between points. The side effect of that is that you do end up with a little bit of GPS drift. Like there I was saying, we were off the side of the road, and we definitely weren't. Attempting to reroute through an actual service station when we were driving worked very smoothly. We hit yes here, and I believe it rerouted us just immediately to the left. I'll fast forward here because we got to a stoplight and that just sat forever. But here you can see that as we were driving, the GPS actually kept up with it very smoothly. And as we approached the service station that was given to us on the map, we were happy to see that a service station actually existed at that location. And up until then, we didn't actually know. But yeah, that is our map at its current state.
So talk a little bit about the highlights of this project. So for the most part, team communication went pretty well. So whenever we needed to meet together or get things done, our communication over Slack, we tended to get problems solved pretty timely. We were able to meet at convenient times when we were all available. Git branch merges went pretty well for the most part as well. Obviously, there was some conflicts, but those conflicts were easily changed because a lot of the time we're working on different things, and when we merge the files together, a lot of the times it just works together because we're working on separate parts of the project. The APIs functioned as we kind of expected, so we had no idea what data we're going to get from these APIs, and thankfully the APIs kind of gave us what we needed to make the features of our project. The code and file refactoring went well, so what I mean by that is towards the end of our project, we all kind of had everything in like one big file, and then we did some effort to kind of separate those things to make it a lot more clear of what's working with what, and it all works together as you saw in the demo earlier. And the initial project goals were met, and our sponsor Iman was pretty content and happy with the progress we made, and he was pretty understanding of the challenges we faced and what we accomplished. So. Right, so some of the lowlights of the project, we started using something called the PyQt library, which is a library, again, with Python that you can use to make a GUI. We switched over to Kiwi because it turns out that PyQt did not work very well with the Raspberry Pi, and we kind of just had to scrap all the work we did early on in Sprint 1 with all that and transition over to Kiwi, so that was kind of unfortunate. We have no GPS, external GPS antenna, so testing live data could only be done outdoors. We couldn't test the GPS indoors, so if we made changes on our computer, we couldn't be like, okay, does that work with the live data? Well, we couldn't know because we couldn't test it inside unless you were, even by the window on the third floor, it didn't seem to get a fix for whatever reason, but thankfully, as you saw in the video, it worked in the car. You also saw in the demo a little bit of GPS drift, and that's just, as Peter explained, is when it's just showing us off the road for whatever reason. During Sprint 3, we changed our project goals a little bit. So originally we had something that had to do with turn indicators. So kind of if you turn on like your left signal to turn left, but you're about to go right, we wanted it to say like, hey, don't turn left, or like, hey, it's going to be a dead end, or something about the upcoming turn. But we found problems with that to where, well, maybe the driver's just changing lanes or something like that. So we scrapped that in change of the service station implementation. And the other lowlight was kind of like I mentioned earlier, we started from scratch. We started from the ground up, so we didn't really. A lot of Sprint 1 and Sprint 2 was kind of just building the framework to get the features running.
All right, so some improvements for the future that our app could take on would definitely be like smoothing out the routes and markers. The routing right now is at a very basic stance. Like it could definitely be smoothed out. You may have seen the marker kind of blinks a little bit. There's a few things with that could just be smoothed out and a lot cleaner. Reading data from a vehicle, that's going to come into having someone who knows a little bit more about the kind of electrical engineering side of it, like connecting these small electronics and reading data from a car and using other sensors, anywhere from like reading data from the car or adding more sensors to the car, like cameras, to receive more information and possibly communicate with other pies or other systems that would be in other cars. Is kind of an end goal from what I understand, as well as just adding more like to our graphical user interface. Right now it's very basic just to get the idea and the hardware behind or the software behind it to work. The graphical user interface could definitely be polished up and cleaned so that it's a lot easier to use for the user. But as of right now, for our reasons, the graphical user interface is fine for our project. But if it's going to go out to be used by users, it should definitely be cleaned up and look a little nicer.
Yeah, that was definitely emphasized by Elon. We would come into our meetings and be like, hey, we want to change this, do this, and improve this. He's like, don't worry about it. We'll just work about the features. I'm like, okay. We'll do that. So. Okay, so a little bit of reflection of the project as a whole. Some suggestions that I would have, and I know Alex likes to hammer this home in all of his classes, is that start early. So you're going to find problems no matter what. Just if you work on it early, you'll find them early, and you can get those solved. I would suggest, so we define weekly goals every week. Yeah, we all know, I think a lot of students here, we do the weekly reports. We're all very familiar with those at this point. I think it's actually pretty important because then you know not only what you're doing, but what your team is doing, so that you don't kind of like overwrite changes. So maybe this person's working on something, and if you work on it too, then it's kind of half of the effort's kind of wasted there. So it's just good to know what you're doing and to stay on track every week. Test new changes. So if you make a change, just test it right away if you can. That way you can find the bugs and fix the bugs a lot easier that way. Dedicate time to documentation and meeting your deadlines. So if you have documentation coming up, make sure you just have like a scheduled plan to get it done with your group. And make sure that whenever you have any questions about the project, so like let's say you want to add a feature or you're not sure about something, always ask your sponsor because they're really the ones who know what they want in the project. So probably a lot better than you do. So always check with them whenever you have any problems. So yeah. Question?
So first of all, a very cool project. I enjoyed the driving demo. It's a lot of fun. So how is this different or significantly different from Android Auto? That's what I have in my car, and a lot of stuff, maybe besides the weather, gas meter is missing from Android Auto, but overall, it's very similar, and GPS is much more accurate, and chances are they can probably tap into the car metrics much easier.
Yeah, no,
So I was wondering what the vision is for this project overall.
yeah, no, that was definitely something that we discussed early on. We're like, hey, this feature would be really cool, and I was like, I'm pretty sure Google Maps already does that. And there were a lot of things that we do recognize that a lot of GPS systems already implement that, but it was kind of as Iman was saying, like the gas station weather stuff are things that aren't necessarily implemented in those already. So we wanted to get that in, and kind of we used like all open source stuff, and that was kind of Iman's big push, is he wanted most things to be open source, and like our GitHub repo is public, like I think it is, maybe will be eventually, and like he just wants the code out there for whoever to use, whoever to improve on. And yeah, I think that was kind of the big push for it, is just the use cases we did, as well as they have some use cases on his end that aren't implemented in the existing GPS apps that would be beneficial. But
so we're just kind of for like open source kind of thing? So
yeah, that's kind of the biggest focus of it.
And I believe also he had talked about this would be a system that you could easily just like plug into your car, and then like if you're driving a friend's car, you could easily take your system with you, plug it in, and then you've got your settings there. You don't have to mess around with your friend's system or anything. Like it's something that can just be moved around and you plug into the car. And
how would you work with the car metrics then? Because let's say Mercedes versus like Audi versus something else.
Yeah,
I'm just curious.
It more of a vision from what I understand. Okay. It's not all the details are fully situated or thought out 100%, but the idea, there's a broader idea, and then the specifics will be thought of when we get to those positions. So
Yeah, for sure.
Very, very cool.
Thank you.
And then the other reason, like, reason we're using Raspberry Pis, again, is because his students over at Deakin and a lot of people over there also use Raspberry Pi. So he kind of felt like, okay, if we can do something on a Raspberry Pi, then they can take it, or his students can take it and work on it themselves, because they seem to really like the Raspberry Pi. So,
any other questions?
I like it too. I think though, isn't kind of the goal not to necessarily make a professional one, but to make something that students can just keep building on
Yeah.
and learning from.
Yeah, that was kind of a big focus. As Nick was saying in the slide about like future plans, it's kind of a starting point to hand it off so other people can play with it, add cool stuff as they want.
Mhm.
Interesting.
Thank you.
Thank you for your time.
Thank you.